All right, thank you. Okay, let's get going, guys. All right, so this is just review again, the first 4 problems. Let me do this one because that one looks a little nasty. The homework quiz is going to look like some of these problems here. Probably more like the first one, the 10 k to the 10 over 2 k to the negative 2 raised to the negative 3. But let me do the third one because that looks a little more nasty. So you have 4c3b4. So the top stays as is. The bottom, you have a 2. And what am I going to put after the 2? That'll be c raised to what power, guys? Right now, c to the first, but they have a negative 5 on the outside. So it'll become c to what now? Negative 5 and b to what? Careful here. 15, good. Yeah, you always multiply when you see a parentheses. When you see a power raised to another power, you always multiply the exponents. Because the c by itself is c1, and of course the b is negative 3. But you got negative 5 on the outside. So you got to distribute it to get that. Then you got to keep simplifying, right? 4 over 2 is easy. What's 4 over 2? 2, right? What's c3 over c negative 5? That's c to what? 8. And then b4 over b15 is b to negative 11, right? However, we don't want negative exponents, only positive exponents in the final answer. So it's 2c8 over b11. And that's all. That's all I got. Here's what I like guys do. In your groups, do the other 3 I've not done. Should only take about a minute. If you have a question, I'll come around and help. I'll come around and help. So while we work on the other 3, I'll come around. She'll take a minute or 2. We'll move on to the next one. Yeah. It's all one letter. It's all one letter. All one letter, guys. All right, so you have a question on second? Yeah. You start off perfectly, and then you have you get a little switcheroo. You see that? It's totally fine. But 6 over 2 is 3, not 1/3. So 3 stays up top.
Right, but then it's the same.
The n goes on the bottom, but the b stays up top also.
Oh.
So your 3b should be up top. So what I would do is don't worry about moving stuff. Maybe subtract everything first and then move at the end. Because then you're moving the intermediate steps, and that's when you get yourself confused. Maybe stay moving the negative part. Guys, okay so far? First one, you should get 80 K4. No, yeah. Yeah, it should be 80 K4.
80.
I got 5.
5.
Maybe I'm wrong. Okay. Yes, you're right. Yes. Yeah. All right. Let me explain the first one here. Okay. Yeah, guys, here's the deal. You have 10K10. Okay. It's 2 raised to negative 3 power times K to what power, guys? 6. 2 to negative 3 is 1/8. That's 1/8 times K6. The 1/8 has got to flip, right? It's got to flip. That's how you get 80. That's how you get 80 K4. So remember, it's a negative. It's tricky because you have negative exponent on the bottom. So it's 1/8. So you divide. So guys, back. You back. Like 4th or 5th grade math. I don't know when you guys do this stuff. You guys are in the pandemic, so it's not a call. What happens when you divide by a fraction? The fraction flips, right? And 10 is a fraction too. Number 1 times 8 over 1. Boom, boom, boom. You get 80, right? Yeah, you should get 80 K4 for the first one. And I'll do the other ones just so we'll move on. Okay, let's switch colors to blue. All right, hopefully you get 2 and negative 10 over 6v and negative 3. Now, what I would suggest that you do, don't worry about moving negative exponents just yet. Save it for the end. Just subtract the 2 and reduce the, oh, and Evie, I messed up. The 3's on the bottom. Yeah, my apologies. The 3's on the bottom. 2 over 6 is 1/3. So you have 1 and 3. You have a v here. And the v's in the bottom too. I'm sorry. Yeah, I didn't follow your work correctly. Now, the part that's a little tricky is n negative 10 over n3. So if you subtract those two, what's negative 10 minus negative 3? So it'll be n negative 7 up top. But we want negative exponents, so the final answer should be 1 over 3v n 7. So subtract the exponents totally. You have n negative 10 over n negative 3. So n negative 10 over n negative 3, that's n negative 7. But you got something bottom out. If you do switch it, that's fine. But you have to realize it'll be n7 on the bottom still. Because if you switch it, then the bottom has higher exponents than the top. But personally, I would just subtract it, just use your properties. Take care of the negative exponent as the last step. Otherwise, you might go in circles. Then finally, this one here. That'd be 3 negative 1 times u to the 1 power over 15 ub5. Now, that's 1/3 up top. U straight up. And 15 ub5. The u's cancel, right? Final answer will be 1 out of 45. Because you have 100, go ahead. It's not. I'll explain why. I know what you're doing wrong. So here's what you're doing wrong. So you got 1/3 at top, right? Yeah. We'd agree with that. 1/3 at top and 15 down below. 15 can be a fraction. Any whole number can be a fraction. Just put over 1, right? That's division, not multiplication. You did multiplication. Okay. So you got to flip it, and that's why it becomes 1 over 45. It's a common mistake, but we just have to make sure we're right. So that's what's happening. Because remember, you have 1/3 at top, 15 down below. That's 15 over 1. That's a flip. And then we'll do 1/3 times 1/15. You get 1 out of 45. Still look skeptical. Yeah. Okay. So you agree to 1/3 up top, right? Yeah. And you have 15 down below. Make it 15 over 1. You see that's still the same thing, right? So we have 1/3 over 15 over 1. When you have 1/3 over this part right here, does that represent multiplication or division? Exactly. So you have 1/3 divided by 15 over 1. What happens if you divide fractions? But what do you do before the multiplication? What's that? Of the second one, right? Then you multiply. Right, 1 times 1. Okay, good. Now you're not skeptical. I like it. All right, let's move on, guys. You could do that if you didn't do that. This 3 to negative 1, it becomes 3 to the 1 power. It's still the same thing, right? You could do that too. All right, let's move on, guys. Let's go to B19. What's that about? You guys might get picked. I don't know what's happening here. Okay. So Arnold dropped the ball during the bounce ball activity. Of course, had in the table. Blah blah. Oh, we did this one already, didn't we? Did we do this one? Yeah. Or hold on. Wait 1 sec. Let me see how it's different then. Maybe the other class didn't do it. That's why. Oh, we only did parts of it. Okay. That's okay. All right. That's fine. We'll do this one again. All right, here we go. So what was the rebound ratio of the ball? So what you can do is divide any 2 consecutive outputs. but you always do the later one divided by the previous one. So the ratio can be thought of like this: 67.6 over 84.5, which is roughly 0.8. I think that's what we discovered last time. Or you could do it again with these two, right? 54.1 divided by 67.6. That's also roughly 0.8. So the rebound ratio is 0.8. That means it loses 0.8. Sorry, it's 0.8 of the previous bounce. That's what it means. So what height did he drop the ball? What you could do is go backwards, right? You go backwards. So you're going to do A4.5 divided by 0.8. Guys? Thanks. So can someone tell me what A4.5 divided by 0.8 is, please? I know someone's got a calculator. Someone can tell me. Thanks. Thanks, Jack. About 169? Wait, 105 or 169? I'm confused. 0.8? Okay, so Jack can tell me again. You did 0.5? Oh, that's okay. 105.65. Okay, now do it again. So it's 105.625. Can you guys do it again? If you do it again, what do you get? We'll say 132, roughly. So it would be 132. That's how you drop the ball. Now, what I want you guys to do is write an equation that represents this data. So y equals a times b to the x power. So what would you guys get for the equation? Now you know the initial value. And what's the base? 0.8. So it's going to be 132 times 0.8 raised to the x power. Perfect. That's your equation. So we found the rebound ratio by just looking at consecutive heights. We went backwards to get the initial value. And because of that analysis, we can make an equation now. That's pretty easy. It's not hard. And then the next one's just kind of more speculation. And by independent variable, we talked about this. Independent is going to be bounce, always x. Depends y. The height depends on the bounce number, right? The bigger the bounce number, the lower the height, right? Because that's just physics or gravity, whatever you want to call it. Okay, D. That one's just more. What do you guys think? If I took a ball, any four of these balls and bounce it, which one do you think would have the highest rebound ratio? Probably tennis, yeah. I'd probably say a tennis ball. So, yeah. But anyway, let's move on, guys. All right, this is new stuff here. Okay, saving for college. All right. So I'm gonna have someone read these questions to me, and then I'm gonna have you guys work on these in groups. Let's go with Hunter. Why don't you guys quiet? Hunter's gonna read for us. Do you remember reading the first paragraph for us for saving for college?
Yeah. You have $1,000 to invest and no.
Guys, quiet, please.
You can invest in bonds which pay 8% simple interest, or put your money in a credit union which pays 8% compound interest. For the option you choose make a difference in the amount of money you earn, examine these two situations.
Okay, so we'll talk about simple interest first. Simple interest, exactly what it means, just uses this equation. That's simple interest. It uses that equation. B, just so you know, will equal 1 plus R, where R is the interest rate. Just in real life, it doesn't work that way. There's more complicated formulas. Like you guys might hear, like, the feds are increasing the interest rates because to stave off inflation. That kind of dictates the interest rate you get when you buy a house or you get a home loan or a car loan, or any kind of loan. So yeah, R is interest rate. So you invest in bonds, your $1,000 will grow, shown in the table below. So you can see we're just multiplying by 8% every time. That's what it looks like, roughly. Wait. That doesn't make any sense. Hold on a sec. If you invest, how does your money grow with simple interest? That doesn't make any sense, actually. Hold on a sec. Yeah, I'm a little skeptical about this. Let's actually calculate. That doesn't make any sense. It's not supposed to go by $80. Here's what we're gonna do. Yeah, that just seems really weird to me. Oh, I see what they did. Okay, never mind. I see what they did. Shoot. Gosh darn it. Okay. Let's back up a little bit. I apologize. I really goofed here. We're not using this formula. Kind of. So what you do is you take 8%. My apologies. I really messed you guys up. Take 8% of $1,000. What's 8% of $1,000? If someone can calculate that for me, please. You get $8? Yeah. So what you do is you add 80. Let's switch colors. Should have read these notes beforehand.
It's not me.
So you simply add $8 each year. That's all you're doing. So it's $80. So it's 8% of the initial deposit. Yeah, my apologies. I really messed that one up for you guys. So the next value is just going to be 1320. So, yeah, that's what's happening there. So you just add $80 each year. I already said that. Now, part B is a little tricky. By what percent would your balance have increased at the 4th year? So you're looking for a percent change. Percent change is always this. New minus old divided by old times 100%. So you're looking for how much it increased in the 4th year. What's the value of the 4th year? 1320. What's the value of the 3rd year? 1240, right? So what you're going to do is when you calculate that percentage, you're going to do 1320 minus 1240 divided by 1240. Or 80 over 1240. And when I calculate that, let me get online calculator here. Let's see here. Math department. Sorry, it's also here. Yeah, so you do 80 divided by 1240. Yep, you get 0.0645. How would I write that as a percentage, guys? What do you do to the decimal point when you write as a percentage? Move how much? 2 to the right. So the percentage drops because you're not changing the increase. The increase stays the same, but the previous amount has increased. So the change is going to be a smaller percentage every time. So by what percent would your balance have increased in the 4th year? 6.45%. So you're getting $80 each year because it's 8% of the initial. That's what simple interest is. So sorry I messed that one up because I did compounding interest, which is my bad. I should have realized that. So that's what happens. Okay. Now the other one's gonna be better, and you'll see why. So here's what you're gonna do for the next one. Now this one, you're totally gonna use y equals a times b to the x. So you start with $1,000, you do 8%, you get this. And then when you do year 2, you get 1160/40. So how is this calculated? It's calculated using that formula. So how's it growing? Exponentially. Where previously simple interest was linear. Simple interest was linear. This is exponential. So how do you think I'm going to get this next one here? What do you think I'm going to do? Yeah, you're going to multiply that by 1 plus 0.08. Because you're multiplying by that ratio over and over again. And you have to do 1 plus 0.08 because the rate's 0.08, but it's a growth, so it's 1 plus that number. Can someone tell me what they get when they do that?
13.48.
Sorry, repeat that one more time.
13.48.
Thank you. Perfect. Let me make it a little more clear. Sorry, guys. So 1360.48. Yeah, so and you could calculate 12, 5, 9. My computer is really slow. 12, 5, 9.71 times 1.08. Yep, 13.6 point. Actually, we'll say 0.49. We'll round up. Okay. So obviously this is better. So what will the balance be at the end of the 4th year? We just did it. By what percent would this account balance increase at 4 years? So it keeps increasing. By 8% per year. Okay. And so which account's better? So which one's better, guys? Second one, the credit union. Yeah. That grows more quickly. So that's compounding because what it's doing, it's taking the previous amount and it's compounding. It's adding more interest to the previous amount. That's why it's called compounding interest. It's taking what it's kind of like if you put money in the stock market, right? You know, your money grows, and unless you took your deposit out or took some money out, if you keep the money in there, it's always going to be a percentage of what was there previously. So not from the initial amount. Sure, yeah, totally. All right. So let's do this next one here. Let's go on to the next one. We'll still have someone else read this. So Davis, do you mind reading the next paragraph on B30? I said Davis, but it's okay. You can read. So yeah, Siri, why don't you go read? That's fine. Davis can the next one. All right. All right. Okay, so I'm gonna set up the graph for you guys, and I'm gonna have you guys do it in your teams. Okay, so let this be 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. So every 2 spacings will be 1 unit. And this is going to be year. That's independent. That's going to be money. And we start with $1,000. So I'll say 1,000 is probably, we'll make that 1,000. So it means each are 250. 250, 500. So when you try to visualize data, be very mindful of how you space things out so it's easy to see, and that it makes sense for the problem you're dealing with, you know? That's 2000. And that's 3000. So what we'll do, I'm going to do blue for simple. I'll make a table for it. And we'll do green for compound. And here are the data points, right? Remember, we started with 0. Was it 0 we started with? Yep. So 0 was 1000. 1 was 1080. 2 was 1160. 3 is 1240. 4 is 1320. So what I want you guys to do is fill out the rest of this table. 5, 6, 7, 8. It should be really easy. For green, 0 was 1000. 1 was 1080. You have 2, 3, 4. And we also do 5, 6, 7, 8. Let me get my notes here so I don't have to keep going back and forth. Yeah, we had a 1080, 1166.40. Then we have 1259.71. And then what do we have for fourth one? Was 3? What was it? 1,300. What do you guys get? What was that one before? Oh, 1360.49. Okay, 1360.49. So fill out the rest of that table, and you're gonna plot the points. So they both start here, but this one grows consistently. So you have 1080. Actually, it's kind of hard to guesstimate. I know at 3 is gonna be pretty much at 1250. So for the most part, that should be straight. But go ahead and fill out the rest of the table, guys, and then graph it, and I'll come around and make sure you guys got it, and we'll do the last problem after that. And you guys can divide and conquer some of the tables and the graph. So we'll just fill out the rest of the table, guys. Okay. So if you want to count that.
You sure? You sure they're just real fast?
Yeah, good. Here, I'll turn off. Hey, Gray's not good color. It's not hard to. We'll go for it. Hopefully you guys are getting this. 1400, 1480, 1560, 1640. So yeah, just a straight line. Here multiply by 0.08 over and over again. So multiply by 1.08. So you get 1,469.33, 1,586.87, 1,713.82. Do it one more time. 1850. So definitely there's more of a separation. Let me graph the blue one again a little more nicely. So at 1, it was what, 1080. And this is at 1250, by the way. So it's not going up that much. At 2, it's 1160, so it's kind of getting closer. At 3, it's pretty much right there. At 4, it's above it. At 5, it's getting closer to 1500. At 6, it's definitely pretty much there. At 7, it's above it. At 8, yeah. So you got a straight line. So that's linear. Okay, let's do the one in green. Still starts here. Still 1080, but it's a little higher, right? And a little bit, it's definitely over 1250. At year 4, it's halfway there. Year 5 is close to 1500. Year 6 is over 1500. Year 7, it's at 1700, probably over here. So the graph kind of looks like this. And it's kind of hard to tell, but that's gonna be exponential. Probably what I should have done, I should have actually just focused on 1000 and maybe space this out between 1,000 more. I probably didn't do the best. I'll be honest, I don't think I spaced it out better. I don't think I spaced it out well. I probably could have done a better job spacing it out. But maybe what I could have done, I'll do this with deep here. I'll do it better with that. But maybe what I could have done was make this 1000, then make this 1100, make that 1200. I probably should have done that, but that's all right. Already committed to this. So any questions? You guys see the difference? So you see why one's linear, one's exponential. Okay. All right, this will be the last thing we'll do for today before we do the homework and the homework quiz. You invest $1,000 credit union from problem B29, compound year 8%. How much you have after 20 years? If you want to earn the same amount of money with bonds and still interest, what interest rate would the bonds need to earn? Show how you know. What could you use in each situation? Okay, so here's what we're gonna do for compound interest. Y equals a times b to the x. And here, you do y equals pretty much mx plus b. So here, a is going to be 1000. B is going to be 1.08. So we want to just find what y equals when x equals 20. Okay. So do that first, guys. So what you get? So plug that in. Tell me what you get. Do a really quick calculation. We'll talk about the second part. 466.0. Sorry, do it one more time. Okay. Let's just make sure we get going to the same thing. Okay, cool. Good. All sounds good to me. So again, let me move my calculator over here. So you're gonna do 1000. What is it doing? 1000 times 1.08 raised to the 20th power. Yep, there we go. So that's how much money you make. 4,660.96. Okay. That won't pay for college, I'll tell you that right now. Maybe it'll pay for one class, if that. But anyway. Now, the simple interest. What are we going to do here? So B is your y-intercept, right? What are we starting with for the simple interest formula? What money we start with? How much money do we have in the account before we start? $1,000, right? All right. And what do you want the money to grow to? You want it to grow to this, right? Now M is going to be the amount. Let me write that more nicely. The amount we add each year. It's not going to be 80 anymore because we want a higher number. So you're going to solve for M. You're going to plug in 20 for X because it takes 20 years. That's why I plug in 20 for X. After 20 years, we want that money. We want the same money. We have to figure out what the slope is going to be for simple interest. So go ahead and solve for M. And tell what you get. We solve for M. Solve for M, guys. Tell what you get. It's a simple algebra, guys, right? Go ahead, Evie. What do you got? 183. What do you guys decimals? Okay, cool. So you have to add $183.05 every year in order for the simple interest to match the compound interest. In 20 years, like, yeah, maybe you start saving before your child's born and you keep saving until they turn 18. So what percentage? Now, what percentage does it have to be? What you want to do is you want to do 183 0.05 divided by 1,000. Because it's always going to be from the initial deposit. What percentage do you get when you divide those two? Yeah. So it's going to be, what interest rate it's going to be? It's going to be 18.3% or 0.31%. That is really high. No one's really going to give you that kind of percentage. So you can see why someone's interest is not really advantageous, because you have to have a much higher percentage to match the compound interest. And what equations to use? Obviously, this is exponential. And that's linear. Independence obviously going to be time. Dependence going to be money. The money depends on time, right? Okay. Any questions? Okay. So what time we got today? 12:05? Perfect timing. We're in the homework quiz. Perfect timing. And then after homework quiz turned in, and if you want to answer homework, you can, or stay with me, you guys know. The homework's attached to this platform. Here we go. And you can use your previous homework on homework quiz. Or if you just know. You probably got stuff. There we go. That's fine too. Okay. I mean, it's really gonna be what that is like a game. Cool, thank you. Yeah, easy peasy, right? Thank you. Thank you. And you guys could just hang tight for a few minutes before we head out to lunch. I know we're all hungry. What? Thanks, Hunter.
Gotcha.